So this will be in your question paper. Find out the complex formed when nickel is heated with carbon monoxide gas. Right? Nickel is heated with the carbon monoxide gas. So what will form actually? You have to find out the complex here. What complex should be formed here? And then you have to find out the hybridization, magnetic moment, spin multiplicity, and nature of this compound. Right? Let us work it out. What will happen? NiCO4 will be formed. NiCO4 will be formed. So nickel tetracarbonyl will be formed here. Nickel tetracarbonyl will be formed here. Right. Let us work it out here. What we have to find out? We have to find out hybridization, magnetic moment, spin multiplicity, nature for nickel tetracarbonyl. Right. So nickel tetracarbonyl. So listen here. Carbonyl is a strong filled ligand, but there is no charge for carbonyl. The charge of carbonyl is 0. Oxidation state of nickel is also 0 here. Right? So let us write the electronic configuration for nickel. Nickel, it is 28. Atomic number is 28. So it will be argon. 18 electrons will go on the remaining 10 electrons will be here. So it will be 3d4s. So 4s2 3d8 electrons will be there. Right? So let us write like this. D orbital. 1, 2, 3, 4. And here this is s orbital. And this is p orbital. This is 3d. This is 4s. This is 4p. Right? There are 2 electrons in the s orbital. There are 8 electrons in the d orbital. That is 1, 2, 3, 4, 5, 6, 7, 8. Right? So what happens? Carbonyl group is a strong field ligand. It's a strong ligand. Strong ligand means what it do? It pushes a s electron to get paired in the d orbital. So the d orbital will be like this now. 1, 2, 3, 4. And here this is a s orbital and this is a p orbital. So here already these orbitals are already filled now. And these 2 orbitals 3d8 only now 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these 2 orbitals will be places. So in these places the 4s electrons are filled. Now what are the vacant orbitals? S orbitals and p orbitals. So how many ligands are there? 4 ligands are there. So in the 4 places, what will do? The CO will place its ligand in 1s, here and here and here. That is the CO will place its ligand. So the hybridization will be 1s and 3p. This is sp3 hybridization. So this is sp3 hybridization. sp3 hybridization. And now let us go for magnetic moment. Magnetic moment. That is mu is equal to root of n into n plus 2. So n is nothing but the number of unpaired electrons. Check out the configuration. Is there any unpaired electrons here? No. So n is equal to 0 here. So mu is equal to 0 here. Then spin multiplicity. That is spin multiplicity means 2s plus 1. Here there is no unpaired electrons. So s is equal to 0 here. So 2 into 0 plus 1, that is equal to 1. So s is equal to 1 here. And then we should go for nature. And nature in the sense whether it is para or dia. Para or dia. Whether does it have any unpaired electrons? Check it out. Whether does it have any unpaired electrons? No. All the electrons are paired. So it is diamagnetic. It is diamagnetic. Right? Okay. So finally we can say the hybridization is sp3 and the magnetic moment mu is equal to 0 and the spin multiplicity S is equal to 1, and it is diamagnetic, right? So these are the conclusions we are getting from VBT. So let me tell you in a systemized method. Now what happens? Nickel when burns in the blue flame for nickel tetracarbonyl. So general electronic configuration is 3D8. So 3D8 in the sense 1, 2, 3, 4, 5, 6, 7, 8, and these two will be half filled. When nickel approaches, it forces these s electrons to get paired up here, so that it will get paired up here. Then the carbonyl ligand will place its electron in s orbital and p orbital, that is one s orbital and three p orbitals. Here the hybridization is sp3 and the magnetic moment is 0 and the spin is 1 and the nature is diamagnetic, right? So this is the thing we can get from VBT. Next, can you do it as your homework? A compound A is formed when nickel reacts with KCl. On treating the excess KCl, a coordination compound B is formed. Identify A and B and give the hybridization, magnetic moment, spin multiplicity, and nature. Shall we work it out? Nickel, when treated with KCl, it gives NiCl2. It gives NiCl2. When treated with excess of KCl, gives K2 NiCl4, right? So this is a compound, that is K2 NiCl4. So for this compound, we have to find what we have to find. Hybridization. First, we have to find hybridization, and second, magnetic moment we have to find, and third, spin multiplicity we have to find, and fourth, nature, either para or dia. So we have to find. So let us check it out. Hybridization. Here, what is the oxidation state of Ni here? Oxidation state of Ni, that is 2 plus x minus 4 is equal to 0. So x is equal to 4 minus 2, that is equal to 2. That is x is equal to 4 minus 2. Or let me write it in detail, that is 2 into 1 plus x plus minus 1 into 4, that is equal to 0. So 2 plus x minus 4 is equal to 0. 2 plus x is equal to 4. X is equal to 4 minus 2, that is equal to 2. So this is here the nickel is in +2 configuration. So let us write the electronic configuration of nickel here. 28, the atomic number is 28. So the electronic configuration will be argon 18, remaining 10 electrons are there. So 3d, 4s, so 4s2, 3d8. So then when it is the nickel 2 plus form, then the electronic configuration is 3d8 only, right? 3d8. So we can write the 3d8 like this. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So there are two places vacant for electrons here, and this is s orbital and this is p orbital. This is 4p, this is 4s, and this is 3d. So here chlorine is a ligand. Chlorine is a weak ligand. Weak ligand in the sense it does not pushes the electrons for pairing. So wherever the place is available, it pairs on. So how many how many chlorines are there? The formula of the compound is NiCl4, right? NiCl4, K2 NiCl4, that is the name of this compound. So 4 chlorine are there. So here one chlorine will place its electron Cl, and here also Cl, and here also Cl, and here also Cl, right? So what is the hybridization? 1s and p3. The hybridization is sp3. Is it clear? The hybridization is sp3. So let us go for dipole moment here. Dipole moment mu is equal to root of n into n plus 2. Root of n into n plus 2. So here the number of unpaired electrons, here 2 electrons are unpaired, right? So root of 2 into 2 plus 2, that is equal to root of 8. And spin multiplicity, that is equal to how many unpaired electrons are there? 2 electrons are there. The formula is 2s plus 1. So that means 2 into half plus 1. That is equal to 2 into 1 plus 1. That is equal to 3. So S is equal to 3 here. The spin multiplicity is 3 here. Right. And the next question is nature. Nature means it will be paramagnetic or diamagnetic. So there are two unpaired electrons, so we call it as a paramagnetic. There are two unpaired electrons, so that we can call it as a paramagnetic. Right? So on a nutshell, we can say that the hybridization is sp3. Dipole moment is root 8, and spin multiplicity is 3, and nature is paramagnetic. Right? So all the answers will arrive. Let me tell you in a schematic manner. So this is output when Na plus 2 is treated with KCl, it gives NaCl2 first, and then in excess of KCl it uses coordination compound K2NaCl4. So the general electronic configuration is 3d8 4s2 for nickel. Na2 plus will have only 3d8, right? So this is the oxidation number, that is there are plus 2 here, there are minus 4 here. So plus 2 will be the charge, minus 2 will be the charge of the complex. Cl is a weak field ligand, so no pairing takes place here. So generally, it will be arranged 3d8. The electrons will be arranged like this, right? The chlorine be a weak field ligand, does not have any power to push the electrons here. So it will take the available orbitals. So this one, this S is available. These 3p are available. So it puts there. The chlorine puts its electron there. So it will be sp3 hybridization. How many unpaired electrons are there? There are two unpaired electrons in the d orbital. Magnetic moment, that is equal to root of n into n plus 2. N is the number of unpaired electrons. So n is equal to 2 here. 2 into 2 plus 2, that is root 8. Right? And spin multiplicity, how many electrons are there? 2 electrons are there. So 2 into half plus half is equal to 1. So 2 into 1 is equal to 2. 2 plus 1, that is equal to 3. And the thing is paramagnetic. Finally, the nature of the compound is paramagnetic.